Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we'll go over how to solve quadratic equations by using the quadratic formula. If you have an equation of the form ax squared plus bx plus c equal to 0, and that 0 is important, any quadratic equation can be solved using this formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We're going to apply this to the same three equations that we solved in the completing the square video. And what I hope you'll see is that in two of the cases, the quadratic formula was much easier to work with. In the third case, they're probably close, although factoring would have been the better way to go anyway. So in problem 9, I have x squared plus 8x minus 20 equals 0. That means that a is equal to 1, b is equal to 8, and c is equal to negative 20. So a good idea in general is to copy that formula down and then substitute in. So I'm going to write the formula again. X equals negative b plus or minus square root b squared minus 4ac all over 2a. X equals negative b, or the opposite of b. And here that's going to be negative 8 plus or minus the square root of b squared, that's 8 squared, minus 4ac, that's minus 4 times 1 for a times negative 20 for c. And that's all going to go over 2 times a, or 2 times 1. We want to simplify what's inside the square root, the radicand, as well as the denominator. So we'll do that next. X equals negative 8 plus or minus 8 squared is 64. Minus 4 times 1 times negative 20 ends up being plus 80. And that's all over 2. I'm going to continue it above and to the right. X equals negative 8 plus or minus the square root of 144 all over 2. 144 is a square root we know. Use your calculator, it's 12. So we have x equals negative 8 plus or minus 12 over 2. And there's a couple of ways to simplify this from here. First, I could divide a common factor of 2 out of all of those terms, and that would work. But I'm going to do it by reducing at the end. So one of my solutions is negative 8 minus 12 over 2. That's negative 20 over 2, or negative 10. The other one, using addition, negative 8 plus 12 over 2 is 4 over 2, or 2. So my solution set contains negative 10 and positive 2. Again, if we had factored this trinomial to be x plus 10 times x minus 2, I can look at that and tell the solutions are negative 10 and positive 2. So if you can factor quickly, there's definitely a lot of advantages here. Let's try problem 10. If you remember from the completing the square video, these solutions were complex, and so that means that we can't solve this by factoring. And because the coefficient of the x term is odd, I really think that completing the square isn't the best way to go after this. So again, let's copy the formula. X equals negative b plus or minus square root b squared minus 4ac over 2a. I teach a lot of classes where being able to substitute into a formula gets used a lot, and taking that extra time to write the formula down first really helps prevent from substituting in incorrectly. Also, I'm going to make note that a here is 1, b is negative 5, and c is 19. Okay. X equals the opposite of b. The opposite of negative 5 is positive 5. Plus or minus square root negative 5 squared minus 4 times 1 times 19. all over 2a, which is 2 times 1. On your calculator, try to simplify that radicand all in one shot. Now that negative 5 squared should end up being positive 25. And so when we square that number, we really can ignore the negative sign. That's going to be 25 minus 76, and that works out to be negative 51. So you can verify that on your calculator, but I'm going to jump right through that. X equals 5 plus or minus square root negative 51 over 2. 51 is 3 times 17. There are no perfect square factors other than 1. And the only thing we can do here is because there's a negative 51 inside the square root, we can pull an I out of that square root. So we end up with x equals 5 plus or minus I square root 51 over 2. And I'm going to write that as 5 minus I root 51 over 2, comma, 5 plus I root 51 over 2. If you remember back to the video where we worked on solving this one by completing the square, this was much cleaner than that. Same thing happened with problem 11, because for completing the square, we had to divide everything by 4 first. We had x squared plus 3 halves x, and we had to take half of that and square it. Lots of fraction issues there. The quadratic formula is going to be a lot cleaner here. This time we've got a equals 4, b equals 6, and c equals 5. I'm going to write down the formula again. X equals the opposite of b plus or minus square root of b squared minus 4ac all over 2a. X equals the opposite of b is negative 6 plus or minus square root of 6 squared minus 4 times a, which was 4, times c, which was 5, all over 2 times a, or 2 times 4. Work out the radicand in the numerator. X equals negative 6 plus or minus. Okay. 6 squared we know is 36. 4 times 4 times 5 is 80, so minus 80. That equals negative 44. The denominator, 2 times 4, is equal to 8. So we need to simplify the square root and then try to simplify the resulting fraction that we get. First, notice the negative sign. We're going to have to pull out an I. Also notice that 44 equals 4 times 11, and we know that the square root of 4 is 2. So that gets us to x equals negative 6 plus or minus 2i square root 11 all over 8. And by the way, again, that 2i comes from the square root of 4 is 2, and because it was negative, it's 2i. I noticed that the 3 coefficients that are not in the square root, so the coefficient of each term has a common factor of 2, and I can divide that from each of them. That gets me to x equals negative 3 plus or minus 1i, or just I root 11, over 4. And I can write that in a solution set as negative 3 minus I root 11 over 4, comma, negative 3 plus I root 11 over 4. So that was the quadratic formula. Not as clean as factoring. If you can factor quickly, factor. Not as tedious in most cases as completing the square, so this would be a better choice unless you've got a second degree term that's a plain x squared, and the coefficient of your first degree term, the x term, is an even number. All right, that's it for this video. We'll see you in the next one.